My name is David Davis. I'm excited to be your moderator for today's event. Now, if you are on this event, it's because you attended a previous Actual Tech Media Summit or MegaCast event, such as the Doing More with Less MegaCast yesterday. And on one of those events, you saw the Datacore presentation. You indicated in some way that you'd like more information, and that's how you received an invitation to this demo event. So this is meant to be a fast-paced, demo-heavy event here that we're doing. We're going to do roughly 30 minutes of almost exclusively demo. And of course, we welcome your questions through the questions box there in GoToWebinar. And without further delay, I'm excited to hand it over to today's expert presenter. That is Mr. Augie Gonzalez, Director of Product Marketing at Datacore. Augie, thanks for being on today.
Thank you, David. Good catching up with you again. So yes, I'll go into a pretty good dive into our vFilO product that you've been acquainted with. I think some of you may have listened in on Alphonse's presentation earlier this week. So this will be a really good combination with what you've already heard. And really, we're going to cover what I consider to be kind of the three biggest frustrations associated with data spread all over the place. And some of those have to do with how do you find a file? How do you, given that you find it, how do you keep that share, and how do you share that information with your colleagues in a way that you can pretty much guarantee that it's what you intended to share with them, especially if those files are getting shoved around between different file servers and NAS devices. The second thing I want to talk about is the typical disruptions that administrations goes through when you run out of space in any one of those storage resources, so that the users maybe have to be redirected to some different directories, placed somewhere else, and how do we avoid that? And at the end of the day, what can we do to reduce the overall cost of keeping up with the rapidly accumulating historical data that's largely goes inactive? So those are the three major things we want to touch on. And the way we will do that through vFilO, you'll see, is three different steps. One of it is to be able to consolidate or aggregate shares from these different pools. And I'll give you this little diagram on that. So put it under a single catalog, or as more commonly used in technical terms, it's a single namespace or unified namespace. So everybody can be in one place. You go to one place, you look at it, you don't have to jump around to figure out which bucket it's in. Then I'll show you how we distribute, how the software actually, I don't do much of anything here, pretty much hands off, distributes those files across the available resources, so you don't have these silos where one bucket is overused and the other one's largely vacant. And then I'll show you how we move inactive data out to low-cost storage, whether that's on-premise object storage or out to a cloud, whether it's Azure or AWS or anything like that, to achieve the overall cost savings. So with that, I think just to kind of present what the environment may have looked like before we got in here, is you likely have been spreading your different folders and directories and shares across a collection, let's say, of file servers and NAS devices. And how you may have done that may have been largely departmentally oriented, so that whatever hierarchies you've built and however you segregate your different bodies of consumers, that's very site specific. But at the end of the day, it's really hard to just pin where best to put anybody, because over time you cannot predict their users. So let's see how vFilO attacks that, and we'll jump right off to the demo that you're so eager to see. So first, to acquaint you with the user interface, it's a web-based environment that we're coming in as the administrator. So the administrator basically has, first of all, a global dashboard. It's basically saying this is what's going on across the system. I'm on a very lightly loaded environment, so you're not seeing a whole lot of activity, but for illustration purposes, at least you get an idea of what's happening here. So the essence of what we have are a number of storage systems. So these storage systems represent the collection of physical devices or cloud resources that we have in place already in the infrastructure. Those may have been silos at one point. What we've done first with the vFilO product is we would assimilate them. That process of assimilating, so let's say I wanted to assimilate a new storage device, let's call it a NetApp share or something like that. I would pull down from here and I see the choices that are available to me. So these are things that the Datacore software is familiar with and says, okay, if you point me to one of these NFS resources or object resources, what I will do is I will grab the metadata from that environment, that existing environment, and I will create a super catalog that rolls that in along with all the other inventory of shares that we've already seen. So you can see here I have a choice of the familiar EMC Isilon, the VNXs, the NetApp cluster modes, SoftNAS, and other NFS. Other NFS would be Linux shares, some of the Windows shares you would bring in here. Those would be places where the data is already existing, where your shares already exist. Then you can supplement that later, and I'll talk about the cloud part a little later, but you can see it all here. These might be additional capacities that you want to introduce into the system afterwards, in which to migrate transparently any inactive data. And you see quite a collection there. There's a few more down here. Pretty good choice. And there's always the generic object storage as well. So that's how we do that. And once we add a storage system into the environment, it basically detects, the software detects that there may be already volumes in here. And so those volumes are presented. So like in the case of the NetApp, we see that there's already a volume inside that one that's already been assimilated. The SMB environment's already been assimilated. And we have some additional volumes that we can assimilate here. So that process is basically saying, let me see what are the collection of directories and files and everything else that exists there, and create that. I can either do that on a read-only basis, which says I'm not going to disturb the existing files. I'm simply taking inventory to understand the makeup and create a single namespace for that, or I can actually start doing something active with them. So that's how we deal with that. The second part of these things are the volumes. So once you have volumes in place, what you'll find is that the vFilO product will start to do its optimizations. Part of that optimization is moving files based on policies or objectives that you define at the site, how best to distribute the information. Because in the original environment, what you have is you have this directory, a specific directory has to sit in a particular storage device. So there's the hierarchy is actually tied, quite constrained to the specific device on which it has originally been deposited. With vFilO, we remove that restriction, and directories and individual files can float based on their characteristics and these objectives anywhere that the system feels is the best place to put it. So we no longer are dependent on the location to do data placement. Data placement is done through machine learning and through artificial intelligence. It's basically looking at access patterns, looking at the objectives you set from a business intent, and then makes good choices on your behalf of where to locate that. One of the things you see, so these would be any other choices, basically saying, I have so much capacity, this is how the capacity is being distributed over here. You can see it across here. And you can also see then you can, from here, we also learn some other things about the system. So the software is not only seeing the superficial name of these resources, but it actually interrogates the physical devices on a regular basis as it does updates to files there, or it's having to read to determine what its capabilities are. So the capabilities are characterized in terms of how many read IOPS am I seeing out of this resource, or what kind of latencies am I encountering anytime I use that. And based on that information, then it can say, well, now I can tell you that the Linux share here is particularly it's not that fast. Okay, it may be one of your more sluggish resources, and you can also understand a little bit about its durability and availability. Now, some of these you can actually override if you know that there's more specific protection that's occurring behind it that is not visible. But certainly what you're trying to say is you're trying to characterize between potential tiers of storage. You might say, well, my NetApp is my top dog here. It's the one that's most capable. My Isilon equipment, maybe that's a little bit longer in the tooth, and I'm seeing it based on the telemetry that I'm getting through this process. And some of these other shares are suitable and they're adequate, but I would not want to put my hot data there. So that's all this collection of information, and what it learns throughout the process helps it make that determination. And from that, we can also set capacity thresholds. These are ceilings when we say if this particular device, in this case the Linux share on which this is sitting, starts to get close to that 75% utilization, we don't want to continue to put anything in there. So a very critical element of what vFilO does behind the scenes is being able to distribute load across available capacity in an intelligent way, so we don't end up with one side lopsided, one of these devices overly lopsided and quite full to the top, where you have vacancies in the others. It evenly makes that distribution, and then it applies additional policies to decide where best to move hot, moderately warm, and cold data. That's what's occurring behind the scenes here. So one of the obvious things that you will see upon first as a user, as a consumer of the shared single user space, is that all the shares roll up. So rather than having discrete, we showed at the origin here, where we had these discrete locations to go to, and specifically if I was sales, I had to go to a specific device to go do that. In this case, what we're doing is collecting all those under an Uber share, which in this case is called data. So that would be the entry point. And we have assimilated the existing shares under that. So you see the sales and marketing and engineering are all now roll up into this one, almost like a root directory. It's another way to look at that. And here, for example, we have the marketing content. Now, what will become really evident is before all the marketing stuff was loaded on a, let's say, a Windows SMB box that was really sluggish. And what the software in this case would do is it'd say, hey, let's not continue to load that guy up. When we have faster resources around here, let's move some of these things around so we get better load distribution. So what you see here is that the graphics, for example, in the marketing folder that used to all be tied to that Windows SMB box are now being distributed by vFilO across the Linux shares. Some of it remain on the Windows share, and some has to move to the Isilon box. It's done that in order to more equitably distribute the use of capacity, and also to better distribute the load. So not all of those marketing dweebs, as we would call, would be banging on the same device. Instead, their load is more evenly distributed. A very fundamental part of that. You see some other points here. You see this alignment. This alignment button shown green, or this the light showing green, is helping you as an administrator understand that the objectives that we set, and I mentioned that several times, are being adhered to. If you were to see a amber or red here, that would say, some of the objectives that we have set up for files based on company characteristics are not being fulfilled. So let's look at at objectives a little bit. An objective is one way to describe that. Maybe look at here's an objective we've already set up. And let's look at that one in a little more detail. So we can make objectives, for example, let's say, if a file is a MP4 file, so video file, and it is inactive for a period of time. So let's say from, I don't know, three days, 36 hours, something like that, 7 days. After some period of time where we feel nobody's been touching these things, more likely in a real formal environment, this would be maybe several months. You'd say, if nobody's been touching these MP4 files after that period of time, why am I keeping them around on my premium storage? Doesn't make sense to do that, because that's just tying up precious capacity. What vFilO will do is to say, okay, I see that rule. I'm interrogating that rule on a regular basis. And based on that, anytime I see an MP4 file that access time exceeds that, it hasn't been accessed by more than 5 months, I am going to take deliberate steps to move it to cheaper storage. So that cheaper storage, we can define those characteristics when we did those original storage systems. Generally, what we would say is we would want to put this into a tier. So maybe the tier that says, if it's in that space, place it on object volumes. Okay, that would be a really good thing to do, because what I'm saying is I don't want to keep it on the pricey one. Object volumes in this case might be my cloud volumes, my AWS or my Azure. And so that is going to drive what we call data mobility, or migration that occurs behind the scenes. And you'll see that occur without user involvement and without administrative involvement. And so that frees up capacity on your premium devices, and it moves those files on a file by file basis, not the entire directory, but it moves those files just like if you were archiving them off to the cloud. One important difference is when that movement occurs, that file's name and its metadata and its position in the directory structure remain there. So unlike when you do a backup and archive and then you don't know where it's gone off to, it's gone off into la la land, and I have to ask somebody to go find it for me and retrieve it and restore it. With vFilO, you can do a self-restore in effect from that archive, because it's still in the namespace. It's still visible to you in your folders, just like if it never went. What you would obviously experience if it had been migrated off to the cloud, we would, some of the steps that we take there include deduplicating the information, compressing it, and encrypting it. So if you were to retrieve that after 7 months and you said, oh, hey, yeah, I haven't, like what happens to us here in some of the organizations is they've got a video they shot a year ago. We want to update that. So at the point you retrieve that, it might take a little bit longer to get it from that cloud because it's somewhat distant and it's got to be rehydrated, but you wouldn't have to jump through hoops to get it. It would be readily available to you. From that point on, its characteristics now say, hey, I no longer fall into this category. I am an active file. I don't meet this objective, so I would be placed back on whatever the directive was, and if it was less than this, I might say, keep it online. So that might be the thing that I would be generally saying for something like that, is the moment it's active, keep it online, because I don't want to have to go through that little delay anymore. And you can observe that kind of mobility through this kind of exotic graph. This basically tells you where files are moving from. So maybe I move from the Isilon to, in this case, one of the DSX nodes, and you can view this as a list as well. So this tells you what files have moved over a certain period, let's say in the last 24 hours or maybe 7 days ago. You can see a much longer list there. And those, what was the reason, the primary reason those moved? It was in many of these cases, it's because of the location choices. So we might have moved it from the a particular source volume to a destination volume where it may have been deleted. Any of those things you would find might have been the reason. In some of these cases, it was simply for protection reasons. So we can also not just specify age here, but we can say we want to ensure certain files gain certain levels of durability. They're very critical files. I want to make sure there's no chance that these things get lost or get corrupted. And I also want to ensure high accessibility or availability, so I can pin the locations of those based on those characteristics that I set. And you can see that the alignment, as I mentioned before, this can look at what are all the reasons for performance reasons, for data protection because of the choice of location, or simply because those particular resources were in heavy demand. There was a lot of contention for it. So that gives you a pretty good feel for what's going on in the system. In terms of the infrastructure and the objectives, there's one other pretty cool thing that we like to show off. And this is the data profiler. So the data profiler helps us assess whether an objective is basically, well, what if I were to change the objective, I'd say, if instead of looking at 7 months out to wait for an MP4 files to move to the cloud, I instead shorten that to say anything that's 4 months or older that hasn't been touched, I should move to the cloud. So I can see how much capacity that would impact, how many files that would impact, and also I can apply. So you can see now here it's basically saying, oh, here's the number of files. So over 230 files would fall into that have been active over that period. And there's some here that are more recently used, so they would not fall within that criteria. I can also apply cost to that. So if I know that my primary environment costs me $200 per terabyte per year, something like that, and my object storage may be in the $1, $2 for it, I can see what the cost differential would be of having this migrated behind the scenes and basically archived to the cheaper storage. It also recognized that the amount of space the files will take up will be reduced when put in the object storage because of the data reduction, the compression, deduping that's occurring there. So you actually have that. And that helps us when the way we price the software, by the way, is we have a different price for active data and a much lower, basically about half the price for any inactive data that's going to go into these other buckets, because we know you don't price that that data the same way, and so you shouldn't be paying the same amount for it. So David, that kind of gives us a pretty good feel, I think, just a quick tour, deep dive in some areas and superficial in the others. Any questions that are coming up from the crowd?
Absolutely, yeah. Some great questions coming in. I know we don't have a lot of time left, but let's see how many of these questions we can get to. So let's see, first question that came in, they're asking, and this might be a good time to kind of reinforce how vFilO works, is how do I protect the data that's stored in vFilO?
Okay, so what you normally would use is Active Directory permissions to establish the access controls. And we assimilate those access controls. So if you have existing permissions, let's say on your SMB environment, those carry over so that we inherit that information through that assimilation process. And then those same restrictions that were in place before vFilO was in the picture continue to be enforced, and that will help coordinate without you having to do anything else. So similarly, you would take a Linux shares and put those into an Active Directory domain, so those same permissions can be, that kind of same control and permissions can be applied to Linux environments.
Got it. Got it. Okay. But am I actually migrating my data into vFilO?
You have two choices. So the most common thing is that the data, think of vFilO as a layer. So vFilO, in fact, maybe you use a little picture up here, is, let me look at the after picture. What essentially vFilO is doing is acting as a data services layer up here above the different storage devices, the existing shares. And so it's simply saying, now I create a single namespace from all of that, and you no longer have to worry about these backend resources or where data is being placed. You just know that your hierarchy is the familiar place, and you know that the permissions are being applied to that. And whether it's a file that used to be here is moved to here and eventually moved here and out to the cloud matters not to you. It's all transparent. In contrast to otherwise, if somebody had actually moved this for you out here, you'd never know about it, and you'd have to ask them to get it for you.
Got it. Got it. Okay. I think that's helping a lot with that question. Another question here, can vFilO help me with high availability or DR challenges?
It can. Good question. So part of the objectives that we set might say, I want to make sure certain files that are critical, let's say some important financial information and the systems of record type information, are maintained in multiple places. I might keep a copy on this box and this box, or at least in two places in my environment to avoid single points of failure. And I also may want to keep a third copy out on the cloud for extra safekeeping, to protect against regional disasters. So I know I have a very distant third copy to fall back on should anything happen. And that restoration is just as easy, because once any of these were to be taken out of service, vFilO knows, oh yeah, I know where else I can get it from. I can go get it from here, so let me go do that. I don't have to alert anybody at the user standpoint. Obviously, administratively, we would sound alarms that say some of your systems are offline.
Okay. Okay. That makes sense. Yeah, it sounds like it could be a big help with HA and DR challenges. Another question here, since we're talking about how this works, how we get started, I mean, how do I deploy this? Is this hardware? Is this software? How does it work?
It's software. It is deployed on standard servers. It's essentially a package that our value-added partners would layer in the environment. So we would scope the size of resources we would need in terms of memory and processing power, and how many nodes of vFilO you would use to handle any data movement. So based on the scale, how many nodes? The number of nodes doesn't affect licensing, by the way. You can scale out this to 40 nodes or keep it down to 4 nodes or 3 nodes, and you're still in good shape. It's same price from a software standpoint.
Got it. Okay. And then, I mean, I guess real quickly, what are some of the most common trigger points where a company or an admin says, we need vFilO? Like what happens at that company? Is it a storage array that's aging? Is it they have to buy new storage and this is going to help them not have to buy it? Or I mean, what are the common scenarios?
Good common scenario is something like this. This NetApp's filled up. Interesting, there's a lot of capacity sitting around here, but that can't be used. So what they're having to do is buy another big NAS. So that's a point. That's where part of that optimization occurs. We say, okay, we take that, we recognize that of this, notice the red and the blue. The red's meant to indicate how much is active data and how much is inactive. Much of this particular NetApp it is what we find most regularly, is being filled up with snapshots and historical information that's not current. And that's tying up this machine. So you put vFilO in here, it's going to say, oh, let me move that somewhere. Let me put that to lower cost storage. And I'm going to free that up. And in fact, what I'll do is I'll move some of this red hot stuff over here because this is my fastest device. So there, we haven't had to, we defer the cost of having to buy additional equipment. And at the point where you finally fill all of this up, then is when you would go to something like this, where you would start moving some of that out to a cloud. So if you have already are being asked to consider how clouds play in reducing your cost as an organization, we can be that trigger. That trigger helps us address your requirements, and we can be that mechanism behind the scenes that's starting to relocate inactive files to somewhere much lower cost.
Yeah, you make a great point there. I think that cloud scenario could be very compelling to a lot of companies who want to use cloud storage, but they're kind of scratching their head like, wait, how's that going to work? And then they see vFilO and like the light bulb goes off like, oh, okay.
Yeah,
this could really work. Yeah. Okay. Well, I think we're running out of time. Last question I wanted to ask you is, I mean, if people saw the demo here, they say, hey, this looks like it can solve some problems that we're, struggling with. How should they get started? What can they do is there a trial? Is there a proof of concept? What do you recommend?
Yes, on our website, you can request a one-on-one session, so we can have a solutions architect spend a little time with you, understand your specific requirements, and then we'll work with the value-added resellers and value-added partners worldwide to help you actually proof the solution.
All right, excellent. Well, it sounds easy to do. It sounds like it could be a great solution for a lot of companies who are struggling with storage challenges. Augie, I really appreciate the demo. Appreciate your time today. Thank you so much for being on.
Thank you, David, for hosting it. Bye.
And thank you to the audience out there for joining today's event. Like Augie said, visit datacore.com, sign up for a free trial, and get your own personal demo. See how it can help you with your storage challenges. Thank you, everyone, for joining today's event. Hope you learned a lot. Have a great day. Bye-bye.